Well, good morning or good afternoon, depending on where you're located, but thank you for joining us. This is our third webinar in our series of asset management excellence in a data-rich environment. So thanks so much for joining us today. We have some really good stuff to share with you and a great panel. So we're going to jump into this. There's a few opening remarks we want to make. We want to talk a little bit about some of the research we've done in support of today's webinar, and that'll help kind of set the table and frame the discussion for our panelists that we'll be chatting with. We have plenty of time for a really good, healthy discussion with our panelists, and then we'll wrap things up. So our panelists today are great. We've done a lot of preparation leading in today's session. Some of you may know both Mike and Nicholas, and had a great experience in the run up to this, and they've got some great thoughts to share with you today. And again, we hope that you can engage with both of them in the discussion when we dive into it rather. First, I just wanted to kind of give a little bit of background, and I think this will help, like I said, kind of set the table for what Mike and Nicholas are going to be sharing with us. What we're going to do is look at maintenance from World War II going forward. And it's actually pretty instructive in terms of where we are today, because you can see there's a natural evolution of how this stuff has all kind of developed and evolved and brought us to where we are today. And of course, many of you today have been involved in a lot of these developments. So the first generation we're going to look at is basically that immediate post-war era, where a lot of what we saw was reactive, and it did evolve into things that you may call routine or corrective maintenance practices. But one of the things that some of you, including myself, who've been in the military, there was always the PMCS, and I think that that started in the military and permeated its way into industry as well. But that's all in the theme of these kind of maintenance routines or practices that, for the most part, were reactive. Some were preventive, but there wasn't a lot of structure to it. That got us to the second generation, which is the next 15 to 20 years after that initial period, where we started to see things starting to look a little bit more like a maintenance program, more systemic approach, a lot more planning of the activities. Much of it was time-based, and I think there's still a legacy of that, of course, in the industry today, but as we see, we're moving forward from there, but much more of a systematic approach to maintenance, where we're seeing less ad hoc and reactive things and moving towards this more predictive and, importantly, measurable world as we move forward and seeing how technology and process continue to improve. The third generation is from the mid-70s to right around the turn of the century, and this is where we're starting to see this movement away from time-based exclusively to where we're starting to look at condition-based maintenance. These two sub-bullets, I think, are really important. Not all assets are created equal. Some require more frequent maintenance or replacement than others. And for some of you who may be familiar with organizations or corporations where they may have remote facilities in different geographies or different areas are going to have different requirements. There may even be a regulatory component in different areas. But one example I often look to is in, for instance, the utility industry, where you have large utilities with large service territories. They may have transformer fleets that are maintained at a very different cadence from an area that may be along the ocean. I'm based in Northern California, where it's always foggy. So those assets are going to have to deal with the weatherization along the coast with salt water and fog. They may have infrastructure in the Central Valley here in California, which is hot and dry, or they may even have infrastructure up in the High Sierra that's buried in snow half the year. So not all assets are created equal, I think, is a big step change for maintenance and asset management practices. This is also where you saw the introduction of RCM, started with United Airlines, and of course has come forward, and we're going to be hearing more about that from our speakers today. Excuse me. And also, like our friend in the picture here, we're starting to see CMMS and EAM. Started with some very rudimentary practices, of course, using the big IBM mainframes, but has advanced today where it's kind of a common practice, which brings us to today, this fourth generation that is often referred to as Industry 4.0. Some of you may be familiar with that term. I certainly ran across it a lot in my research for today. Heavily digitized world, and I think we're all experiencing this and have different levels of where our operations are being digitized. But there's a few things that we'll talk about today, and if you followed this series, we've touched on some of these during the year as we've gone through the different areas. But when you look at AI, Do you have those data sets? Are you training those models that are enabling you to do things more predictively? The digital twin is that digital representation of the physical world and how you can do modeling and be more predictive. And of course, augmented reality is it's kind of a cool technology, but I think we're also seeing where it's real important in terms of knowledge transfer, bringing on new employees where you have that 30+ year maintenance guys who are retiring. This is one tool that's being used to help augment that. As well as there's some really interesting business practices where this can really affect the bottom line. So a lot of cool stuff happening in this digital world, but we put data exclamation point because it's really easy to get caught up in how cool all this stuff is. Like even the picture here on this slide, I mean, that's really cool. Without that underpinning of data where you're getting into data management, data availability, data cleanliness, data readiness, data governance, that's a really important underpinning as we get into this world that's more digital, it's more automated, and ultimately more predictive and prescriptive. In fact, it's so important that part of the research that we did for this today is a series of interviews. And this gentleman, Nick G's, he runs an RCM software company. And of course, he runs into a lot of this in a lot of different industries, from healthcare to manufacturing to energy. And I like what he said, that it's a beast and you need to keep feeding that beast. And he's right, because you have to have the right data in the right place at the right time. How it's generated, how it's leveraged, those are all huge, huge issues. And I think we want to keep that maybe in the back of our mind as we hear from today's panelists, and they're talking about not only the technology stuff, but the business process stuff as well that's enabling a lot of these newer maintenance and asset management capabilities. So that's just some thoughts that I think will help maybe prepare us for the deeper dive that our speakers are going to do. And I'm going to introduce them one at a time. First, excuse me, we're going to hear from Mike DeSabri. He is a product manager at IBM. So let me just tell you a little bit about Mike's background. So Mike is a product manager, is responsible for RCM and generative AI solutions. He has 40 years of client and technology experience, both as a client and as a consultant with Big Four firms. His clients have been Global 500 companies, including life sciences, biotech, oil and gas, and metals and mining. Mike holds an electrical engineering degree and an MBA, and also has minors in math and lean manufacturing, and is a former certified maintenance and reliability professional with the Society of Maintenance and Reliability Professionals. He's passionate about leveraging AI and enabling technologies to develop product innovations that optimize asset performance, maintenance productivity, personal safety, sustainability, and the human performance. So Mike, I am going to hand it off to you, and the floor is yours.
Great. Thanks for that introduction. So when we think about data and the evolution, it's like, where do you start? So I get this questions from customers. And we kind of look at it in a journey, and that's what this slide depicts. So if we go across the top, there's some key steps that we want to hit on. So we identify the critical assets, we refine that equipment data, we develop and optimize reliability strategies, we execute those, we start to go into performance monitoring, and then continuous improvement. But when you look at it, the journey always starts, and people often jump over this. It really starts with your asset hierarchy. So if you look on the left, what is your asset hierarchy currently today? What's the condition of that? And are you lined up to some type of standard like an ISO 14224? Because this becomes the backbone of what you do. So as you're going to implement your EAM system or improve it and implement APM, asset performance management, like monitor, health, and predict, and then now we also have reliability in the suite with reliability strategies. Where do you start? You want to get that registry up to snuff. And sometimes that actually means going out into the field and collecting the data. I've been involved in projects where it was an explosion at a refinery plant, killed about 15 people, had to walk down 230,000 assets to basically create that asset registry as the start of the process. So I see this process repeating over and over again when people get very serious about their maintenance, their operations, and also reliability. Then you look at it from the functional importance of those critical assets. So this is basic criticality analysis. So what are those top 20% of the assets that you're going to focus on? You're going through that process now that you have your registry. And we go to the next one, we start to develop the reliability strategies. Now within the Maximo application suite, we have RCM. It's called Reliability Strategies. It's two things. It's a software, but it also comes with the library of FMEAs. And some companies shy away from doing reliability because it's so hard. Because of all the data that needs to be generated, the workshops you have to create. Now, typically on average, we say an RCM study takes about 600 hours, but the return on investment is significant. In one case, company we're working with, they reduced their maintenance costs by $700,000 in the first year, and then also increased their finances by 40 million. So sometimes it can be very impactful, both for the top and bottom line. And now that that's part of the suite, that information, that data is there for you to leverage and then apply. And once you go through the studies, FMEAs or RCMs, however you categorize it, you start to look at optimizing the strategies you have. So you look at your PMs, your inspections, is it condition-based maintenance? Do you have the right strategy for the right asset at the right time? And now with advanced technology, we start looking at analytics, anomaly, and prediction. Maybe in some cases it might be an equipment modification, or we're adding spare parts, whatever the mitigation strategy is that we put together. But if you look at that, that starts to tell you where to strategically apply different parts of your system. So if the strategy says we're going to do PM's inspection and some time-based maintenance, great, let's use manage. If we're starting to get into the analytics, then we start looking at something like monitor, right? We're going to get the time series data. And I'll talk later about the IT data, being EAM, the OT, and the IoT data, and how that all comes together. But that's basically where you get started. And then on the execution, you have the different personas that are involved here. So you got maintenance planners, you got technicians, control techs, project managers. So basically, they take all these strategies that you created. And if you look back now, your EAM system now has a strong foundation. You have great reliability strategies in place. You have PMs, and you're starting to connect to equipment. So you can see the maturity of this. And where we see companies, sometimes they'll start with just the AM first, but in parallel, run a POC to do more of the advanced anomaly detection and prediction, which is often the case I see with customers. From there, we go into the performance monitoring. And this is where we start to look at things from minute to minute to hour, and that's where the product health comes into play. And we see companies use this as they take the data coming from their EAM system, saying what is the health of my maintenance program today, and then they also look at the time series data via the anomaly detection or the prediction, and bring that to create a health score for an asset or maybe a part of your plant or a system of assets, so that you can see this almost on a near real-time basis. And what I call this is like the always-on supervisor. So it's always watching. Once this is set up, the data flows. It's easy for your technicians to begin to shift, to come in with the supervisor, look real quick, what's the status, my health, do I have anything that needs immediate action, what's my PMs for the day. So you can kind of keep it all in balance and make your whole organization much more effective. And as we go into continuous improvement, there's things that may come up. There may be some bad actors that start to rise. There may be some additional failureness, but we feed that back into the FMEA so that information is not lost. So we talked about the aging workforce. That can now be captured and fed back into your library so that it can be reused again. So this is where we see companies also excelling, taking this information to improve design, so design for reliability recommendations. And again, it's all in this virtual circle that you create. We're looking at end to end. So when you look at your organization, like kind of where are you on the spectrum? Where are you in your journey? Where's the possibility where you can go? This kind of gives you a little bit of a roadmap of where to look at and where to start. I'm sure when you talk to Acritize, they'd be happy to give you a baseline assessment of where you are and where you can go. And the underlining piece of this that often gets missed, we get focused on the work, the technology, the data, is the business case. There's going to be a business case that's going to support this. So when you go to management and you want to improve this and advance it, there's definitely a return on investment that you will look at. That's going to be very important as you start to go through and execute these projects going forward.
All right.
So Mike, back to you.
Thanks, Mike. We're going to hear from you again when we get into the discussion in a few minutes. But first, I want to introduce our other panelists today. Nicholas Despain. Nicholas is the Director of Manufacturing Solutions at Aquitas. He's a 30-plus year maintenance and asset management leader with experiences based primarily in the food and beverage industry. He's a seasoned professional in the maintenance operations and is proficient in best practices for enterprise asset management systems and industry-specific challenges facing food manufacturers. His expertise in maintenance and reliability is the result of 10 years as the Senior Director of Maintenance Operations at a large food manufacturer and several management positions in the industry prior to his Senior Director role. During his career, he has supported various plant positions in operations, engineering, and maintenance, and has led several company-wide project teams in evaluating, selecting, and implementing various maintenance reliability programs, learning and improving best practices along the way. Nicholas specializes in advising companies on their maintenance and overall asset management strategy, leading reliability improvement projects, process safety management, and working with organizations to deliver world-class digital transformation strategies. He holds a BS in mechanical engineering from Brigham Young University. And Nicholas, the floor is yours.
Thanks, Mike. When I was asked to put together a couple of slides on this evolution of maintenance, I got to thinking about across my career. I started in the maintenance world from the operations side. I've been in the operations side. I'm an end user of many of these tools that have been mentioned. But for us, it's always has been about data. But I started back in the 80s as a maintenance supervisor. It was a paper process. We had data entry clerks that would provide us printouts, and we would have to go get the mechanics to do the work and then fill out the forms. And then if they couldn't read it, we'd have to go back and get other informations. These were on clunky green screen computer stations. In fact, I recall I wanted to do some work at home, I think, one time, and I took home the first laptop we had. It was the size of a carry-on suitcase on there. So the user interface has always been part of the issue to get information in, because if you need the data, you need to be able to get it out. So we were part of big teams to create smart naming conventions to make it easier, but still the analysis was limited. During that time, though, as the advent of personal computers and computers came on board, CMMS has improved, but we also got a great tool from Microsoft, Excel, so we could start filtering some of these things. But once again, we grew up on these tools that were clunky, but we still had to keep the operation going. In fact, I distinctly remember emergency work orders, which is a key part of what Mike was talking about for cause analysis. We didn't even record those. We put them in logbooks, and you had to go back through the logbooks to review that kind of data. So there were a lot of restrictions, but as the advent of the computer and the user interface changed, productivity improved. So at that time, low wrench time, minimal analysis, but we always had to have a lot of resources. Whereas today, as we go to the next slide on there, it's incredible what's happened in the operation. We can be near paperless right now, and the documentation is not having to go through clerks, but mechanics, and teaching mechanics how to do that, and using PCs where you could do research at your fingertips and find smart data. You know, it is about the data, but even today, there are a lot of people who don't quite get everything in there, and that's those people who set up your systems and those people who use your systems. I distinctly remember one time as we were converting one of our processes to a more advanced system, and we were talking about the reports needed. And we had a lady who was in charge of an inventory center, and she wanted to make sure we had the 422 report on there. And we were kind of looked at her and we were going, okay, we're in inventory. I don't remember what the 422 report is for. Well, you know, the one I have to print out and then scan back in so I have a copy of it. Okay, what report is this? Well, you know, it's the one where I push 4 and then I push 2 and then I push 2 and out prints my report. I mean, they still haven't got the idea and the concept of how to use that data and make that user interface work. She was used to the old-fashioned process on there. Whereas now, querying the field and querying the information, you can have incredible real-time data and real-time analysis, but it still is about the data. If you don't have the data in, and you have some of those old smart type systems on there, smart naming, smart numbering, you're going to get what you've set yourself up for on that. Another example I like to refer to on there too is we try to smart everything and make it easy on there. Failure codes. I've been in areas where there's hundreds of failure codes, thousands of failure codes. Why do you need so many failure codes? Because the user interface just gets more and more complicated. You're dealing with mechanics or people who are fixing things. They're not data analysts. They're not going to intuitively know all those steps. But if you set up a hundreds of different failure codes and you have to go through lists, I can tell you right now, the mechanics I've worked with, you're going to have everything listed as other, or everything's going to be at the high, at the A's, because you've got an alphabetical list and it's just easier to select the top one. But if you do something simple like 5 failure codes that I'm an advocate for, it's easy to pick the right ones and then make the data work for us. So what I'm talking about from an end user, now that we've got a better user interface, it's easier for operators to enter the information. We need to make it right for them. And things like 5 failure codes makes it right for them. Or maintenance strategies. What is your maintenance strategy? You can do great analysis and very expensive PM optimizations, but bottom line, if you use your tool and identify what your strategy is, simple sorts and simple evaluations can be done by just about anybody. I've had mechanics be able to go and do a quick research on, well, the asset strategy on these 10 pieces of equipment, say these 6 have to have PMs, but 4 of them don't have a PM, so those are the ones I'm going to go work on. That instant information of the data to do something with it makes a difference. We've all heard the definition of insanity, doing the same thing over and over again, expecting different results. The data from our CMMS and EAM systems should drive change. If it doesn't drive change for us to do something different, it's insane to expect different results. So use that data, but the data's got to be in the system, so we've got to make it easy from a user interface and get it out. And with today's systems, being able to even do voice dictation on there, it's incredible how the wrench time has improved, reliability activities have improved, effectiveness has improved. So to me, one of the biggest evolutions since I started back in the 80s is that user interface, so that end result, the data gets in and we can get the data out, but we got to make sure we're keeping up with our philosophies with the technology and not making it difficult for the technicians to put in the data, or make it difficult or awkward for them to have to select through 30 lists to pick the right thing. We've got to make it so they can get the data in and we can get it out easily. To me, that's one of the biggest changes for productivity in the evolution of maintenance. Mike?
Great. I love the 422 report. That's my favorite. My favorite one.
Yeah.
It's a great story. So again, we're going to encourage our audience. If you have questions, please put them into the chat. We would love to hear from you. I've been keeping some notes here and had a few questions for our panelists today to kind of get things rolling. Mike, I'm going to start with you, and I appreciate your slide. It was kind of a walk through a process, which was a great way to look at that. So let me take a step back and as you look at this maybe a little more broadly, when you look at the current advances in technology, and we talked about some of that, how we've come into this digital world, what types of data are you seeing that's critical? Again, data rearing its head again. What type of data do you see as critical for the enterprise when you're looking at it in terms of reliability and maintenance and operations? So what are the types of data that folks should be really keenly aware of?
Right. Yeah, I put it into three buckets. So one is IT data. So basically what's in the EAM system. And the other one is OT, information that comes out of your control systems, your PLCs. And then the third one is IoT. So if you're adding sensors to your production line or to any type of equipment, that's sensing like vibration, temperatures, those type of things. So those 3 sets of data are very, very key to have those harmonized, and what I call them contextualized. That basically they have to be in sync. And it goes back to, again, starting with the basics in your EAM system. You have that hierarchy set up right. Is the standards set up correctly so that you have the right type of asset classification? As Nicholas is talking about too, is you got the right failure codes assigned to those assets. So when you close the work order, you properly can aggregate that over time, because that also helps you pick out the bad actors, what to focus on first. So that basic really gives you the backbone and the structure of your data, and then how you're going to integrate that with the IoT and the OT data. So I'll give you an example. We did a project, actually largest car manufacturer in the world. So we were putting EAM, monitor, health, and predict in a production line in a live system. First thing we did is we made sure that asset registry was right. We had the right locations. We had the right assets. We had the right classifications. We also looked at it from an FMEA standpoint. What were the failure modes? Those helped us identify what specific areas we'd actually start to apply analytics to. And then when we looked at collecting the information through something like Monitor, we actually aligned the hierarchy to the tags in the system of the PLC. So those were in harmony. And that helps us all work together and automate the information. So if you start to get alerts and things like that, it can flow back to the asset automatically and start to aggregate. So you can simply see it by a push of a button. So when you bring those three things together, the IT, which is the EAM data, the IT, the OT, and the IoT, that's really what they call contextualization. And that's real key now as we're going into these more advanced solutions. So you got to get the basics right, your EAM system, and then you can add to that.
That was a very complete answer, but I had one follow-up question for you.
Okay.
You mentioned time series data both in your opening remarks and as you were just describing kind of the data play right now. In your experience, I don't know if this is an even fair question, how fair, or I'm sorry, how seamless or easy or difficult is that integration of the time series data into an EAM? You know, are there data quality issues? You know, it always looks great on like an architectural IT architecture diagram, but then when you're actually doing that integration, sometimes it's a little messy. What's your experience been with that?
Right, that goes back to the structure of the data and having standards. So if you do have a good EAM standard and your hierarchy is correct, like line to ISO 14224, it's a lot easier to align the IT data, the OT data that's coming in from your PLCs and things like that. Because if not, it's a tag, and that information comes through the PLC, however, it's the historian, and then into your EAM system. That tag also needs to be aligned somehow to where it's going to land on the asset. So tags are not assets, and assets aren't tags. So the work, the trick of the trade there is to get those to align. The first time you do it, to get the groups together, I suggest you get people that really know maintenance and the EAM system, your controls tech that really understand the data that's coming out of the historian, bringing them together in a room, along with the architects that actually run the physical infrastructure of this that are basically going to bring that together. If you get those three in a room and go through the process of aligning that, you'll learn a lot the first time you do it. It takes a little bit of time, but once you get that knack in your own company, then it's easy to scale.
Okay, good, thank you. And Nicholas, I want to pivot over and ask you a couple of questions. You know, your experience. You know, I want to ask a question. This can be either a you know, I kind of view this world through the technology and the process, and I realize the two are not discrete. But when you look at how technology has developed and evolved, and how business processes have changed, what's one that you can point to and say, "Wow, this is a leap forward," and being able to tie that leap forward to something that's very measurable, like, boy, it used to cost us this much and take us this long, but when we implemented A, B, or C, you know, it had this impact around finance and safety and reliability and you know, errors. And can you maybe cite one or maybe two where you can really point to that leap forward?
The thing that comes to mind the most, because like we've talked about, it's about data, but the thing that comes to mind the most on this, in this evolution, is the availability of the data. We all know that there's many of these programs and processes that need to be done, but you use data to make those decisions on that. The availability of the data in the right people in the right hands can be incredible, even for non-maintenance people in the finance area. Making that data available that comes out of the maintenance systems to them real time helps them understand the process, our operations team, our maintenance team. So just by having the availability of the data, regardless of what tool you use, because every one of these tools needs the data. That's probably the biggest step right there, because you can start easy. The 80-20 rule says start with something simple instead of doing the full-blown system. You may need a full-blown system on an airplane, but if we're making potato chips, maybe the fryer doesn't need the full-blown system, but it needs to run. So what data tells us to keep that fryer running so that the chips can come out cooked at the right temperature, the right crispness on that. So I would have to say it's the availability of the data really at our fingertips in a lot of different formats.
You know, on that, when you talk about data availability, and I'll ask this to both of you, what percent, maybe not what percent, but to what degree are you seeing your clients and partners moving to the cloud? Like when you walk into a manufacturing facility or, you know, a large energy company or what have you, you know, how many of them are like, well, we're all in the cloud now? And so there's another layer of stuff to do because, you know, you have to have cloud connectivity and all that kind of stuff. But are you seeing that as a big thing right now in terms of, A, are they doing it? And B, is it improving that data availability?
That's more from a back end standpoint. The front end users don't really care as much. Although the front end users, if you stop and think about it, we're all on the cloud if we have a cell phone. So
Sure.
everybody has some degree or some level of it. So it's really about how you get that information out on there and in what formats and what processes. I've seen a lot of more shift lately to the cloud in making that available. So it's across not only in the environment, but in other places from a corporate standpoint or those that have the opportunity of working from home. Well, bottom line on all of this, it's what you do with the data too. I mean, there's another step in there. We talk about data, making data available and making data useful, but as leaders in the organizations, what are we doing with that data? I mean, I'll boil it down to something simple. If we do PMs on a weekly basis for 52 weeks out of the year, and we never generate a follow-up work order, those mechanics are going to get a little bit frustrated. Why am I doing this if nothing helps? But if we analyze that data and say, you know what, this is something we don't have to PM anymore, let's get rid of that and do something else, that's doing something with the data. That's what leadership is all about. If we don't do something with the data, regardless of where it's coming from, why are we even doing it? Why have a CMMS if you don't do something with the data? And I think that's probably the biggest thing that I haven't seen enough of yet, is leaders doing something with the data. It's there. We've been tracking it for 5 years. Shouldn't it tell us to do something different, especially with the lack of resources or the new mechanics coming on board? If they're not going to be coming on board, we have to do more with less. So why are we doing things that the data says we shouldn't be doing?
Right, right. And this comes back to the point you made in your opening remarks about if you're going to be doing this, you need to be looking for ways to drive change. Because again, the business environment is changing. That landscape is changing in terms of the staffing and the technology, et cetera. So yeah, I'm probably going to revisit that leadership point with you in a little bit. Mike, I wanted to go back to you, and we've talked a lot about data, and kind of the next step in discussing this, I think, is where is this going? Particularly, you know, you have generative AI in your job title, so I'm interested in where you're seeing this maybe being applied. And are there new or different data sets that maintenance and asset management leaders should be looking to? You know, we want to. This is what we want to be doing 2 years from now or 6 months from now, and we're not capturing that data. So, what does that look like in terms of new data sources that may be enabling some of these newer AI solutions?
Right. Yeah. So if you look at generative AI, and we call it Watson X at IBM, I've been fortunate, been working with it for about a year. So we've been applying it to automate creating failure mode and defect analysis. So I'll give you an example. One company takes about 600 hours, their best people offline, to do an FMEA study. So often doesn't get done because you can't have your best people offline that long. So what generative AI would do is actually go into your raw data of all different sorts, and be just like if you were going to sort through it yourself, but harvest from that the particular information, like what is the failure modes, what's the effects, and so forth, and actually complete the FMEA, but not to the point where you would just say go ahead and use it. It's to the point where it's supervised. So as the reliability engineer that's working with this, you would say along different steps when it's generating the FMEA that you approve it. So we've tested this with customers. We tested at the Society of Maintenance Reliability Professional Conference, also in a webinar. So it was about 300 attendees. So 80% they would use the demo that we did as part of their tool. The other place we're exploring to apply it, we talked about work orders and work order data and closing it and properly putting the right failure code on it. So generative AI will go into all your work orders and actually put the right failure code on the work order and close it for you, right? So we're using that now. It's been built, the prototype's out, the MVP is in place. So for IBM's worldwide facilities, millions and millions of square feet, and I think it's like 35 countries, we're using that to close work orders in Maximo. So it's starting to be used now with customers. We're also exploring other areas to help assist with the initial configuration of systems and improving that as well. So, I get fortunate to work with a lot of research scientists, both inside and outside the company. And you see the stock markets recently, just some companies doubling, IBM too. Their stock went way up because we're ahead of the curve here. They're saying that over time, just like the internet, this is going to be more profound than the internet. And based on what I've seen and just in the short time I've been working with it and how fast it's maturing, I truly believe it's going to happen, right? And it's going to be part of a mobile device. It's going to be on something that a technician carries around. You can ask questions of it and it'll go find that answer for you. So it's going to use all your data that you have. Sure.
Are you finding that's good stuff? And I think we all can kind of visualize what that would look like in terms of implementing it in our organizations. What type of pushback are you getting? Like, whoa, now hold on, okay, this is really bleeding edge stuff. We want to make sure we stick to our knitting, and we've got something that works here. So, are you running into some of that? I'm sure to some degree, but what does the pushback look like?
Good question, Mike. I had the same kind of apprehension when we first started bringing this into the public view. Mm-hmm. But to my surprise and delight, there's a lot of curiosity, and it's more they're skeptics. It's just like any good maintenance or reliability person. They're skeptical until you prove it. Show me the details. Where did this come from? How did it work? So it's more of a skepticism at first, but once they start working with it and they see it and they become more comfortable, there's less and less of that. But like I said, in the first 300 people that seen it, there's about 80% said they would use it today if it was available as they would supervise it. So it's like I tell my kids, my adult children, AI's here, it's coming, it's getting bigger, and the people that use AI in their jobs are going to be the ones that are going to be successful. Yep. I think it's also going to help close the gap for some of those aging workforce issues that we see.
Right. Nicholas, I wanted to go back to you about a comment you made about the leadership role, but I had a question from the audience that I wanted to ask you. On your slides, you pointed to in the before world, smart naming conventions, and then smart search fields. Can you just talk a little bit more about that? I think that has a lot to do with how you're structuring data and things of that nature. Can you just speak to that for a minute?
Sure. Smart numbering, back in the olden days, we would have a series, and that could be anywhere from 4 to 25 characters, that the first characters were the plant code, the next characters were the line codes, the next characters were the machine codes, the next characters. So basically a parent-child hierarchy built into the naming convention itself. Whereas today, and I even fought this battle when I tried to bring in new systems and new processes on their new CMMS. Everybody wants a smart asset numbering so you know exactly where it is. But if you have a description of where it's at, and you have the parent-child relationship, and you can search on the descriptions, that's the smart searching I'm talking about. You don't have to have a smart numbering system set up for it. So you don't have to spend all that extra time or development. I just recently went somewhere where they had, believe it or not, 8 different line codes on a cost center code, and they wanted to look up the 5th section in there. Well, that smart numbering made it difficult. We were able to narrow it down and find that 5th section on there, but you're just making it harder than it needs to be by trying to create a smart system. Same, like I said, with failure code, thousands of them versus 5, there's a big difference on that because you can use smart searching, a form of AI. It's early versions of it. I mean, we talked a little bit about the AI thing on there, and from an end user standpoint, we've been doing variations of this for a long time, but what are the right steps, and what is the right cost for us to do, and how can we start simple steps to show that it's right, so that when IBM has this great tool, yes, we're ready for it. Because jumping from 0 to all the way there, that's hard for a lot of us
Right.
end users to do. So getting it there and showing that there is value by saying, first of all, let's analyze all our top equipment problems on there, and okay, we don't have a mean time between failure, but we have emergency work orders, and we know how often that happens, and if we average every 45 days, let's start with that. That's the step in the direction that, all right, now when the system tells us these things from an AI generative process, that you've got problems with this, you should do a PM within 45 days, it already resonates with us because we've started the process. You're doing something with the data, like I've talked about.
Right, right. Good. We do have another question from the audience, and our colleague Carly is going to share that with us right now. Carly, can you let our panel know what the question is?
Sure. The question is, as a mid-sized manufacturer, it seems like we're struggling just to get work done. FTE shortages, difficult to print out PMs, let alone get them done in time. Where or is the best place to get a quick win?
Well, that's like a home run type of question. That's aiming for the fences. What do you all think of that in terms of maybe there's like Nicholas, I heard you say, you're going from 0 to fully engaged AI. That's a big leap. What are some of those steps? Maybe I think that's maybe part of the question. What are some of those steps look like in terms of getting some wins and leveraging the data and the technology and the process with that?
Well, one of the things I'll refer to, a colleague of mine used to talk about, let's get rid of the recreational maintenance activities on there. So if we're shorthanded with people and we're doing things for the sake of doing them, and the data is not telling us that it needs to be done in there, let's start getting rid of some of those things so that we can use the existing resources for the right tools. Then also use some of these other advanced tools and the operators to do some of the pre-analytic work for us. It doesn't require a maintenance mechanic to look and see if something is wrong on an inspection on there. It could be an operator doing those things. So using the right tools and the right resources at the right time and getting rid of what the colleague referred to as those recreational activities. You have data right now that tells you you are doing some things that don't need to be done. You're shorthanded. You're not getting all the work that needs to be done. Get rid of those things that are not getting things done. And one of the places to do that is, what is your asset strategy? If you have an asset strategy that, another example, I inherited a advanced condition-based monitoring program that we were doing vibration analysis on all of our motors. One plant took it clear down to 1 horsepower motors. Well, if you stop and think about it, 1 horsepower motors, those are throwaway motors. You really are not going to rebuild those motors, or even gearboxes at this point. You can buy sealed gearboxes that last 10 to 15 years and just replace them. If you have a sealed gearbox that lasts that long, why are you doing a monthly PM on it? It doesn't need to be done. So your system already has data. Do something with it. Get rid of the ones that aren't helping. Then you'll have more time with your limited resources to do what really needs to be done.
Yeah, I'd say add to that. You're in a tough spot because you have to be reactive and proactive at the same time, right? And that's hard when you kind of do the day-to-day job. Yeah, I think one thing, we talked a lot about failure codes. I think all the implementations I've done, I would always preach that that's probably one of the most powerful things of your EAM system. So as you're closing those work orders, and properly categorizing that, that's going to allow you to do an easy report, like a Pareto chart, to say, where are my bad actors? And as you start taking the worst bad actors out and then resolving those problems that they have, your reactive problems are going to go down over time, right? So that's going to allow you to focus on more proactive things. So that would be my suggestion, is start there. Is what's eating your lunch, right? And that really is one way to kind of help you prioritize where to focus, to go from that reactive to that proactive.
Mike makes a great point on there. You know what your top 10 or top 20 are. Go look at them. And if the top 10, 5 of them don't have PMs, then go fix those PMs, and your reactive problems are going to go down, just like Mike says on there. So focusing on the few versus the many.
Yeah, and then you look at that, you got, if you got your code set up right, maybe it's an operator issue, right? Maybe the operator needs training. It's you always get the new guy on third shift, right? There's a lot of turnover, so that person's having issues and beating on the machine inadvertently, just thinking they're doing the right thing. So those things will pop out. It's in the data. I guarantee it's in there already, but it's getting that maniacal focus on getting rid of those things that are really the most reactive, which are your bad actors. And you'll also find that those tend to be the ones that draw the most attention, right? If something goes down, it's that machine again. You know, the bosses, the operations people are upset. It's maintenance fault, all those things that cascade after it. But I think that'd be a kind of a quick way to kind of get a fast start to change it. But I empathize with your situation because I know a lot of people that have been in that. But you know, start with something. It's definitely, you got the right mindset thinking about it.
Great answers. Thanks, gentlemen. I do want to come back, Nicholas, to you and speak a little bit, if you will, about the role of leadership in this world that we're in today. It's heavily digitized. We've talked about data. We've talked about the changing workforce. What are a couple of things that asset and maintenance management leaders can be doing to really help drive that change while still maintaining or improving reliability and the financial aspect and safety? What are those things that leaders should be doing today? And again, I think the background noise here is also staffing implications as the skill sets need to change and the aging workforce phases out, et cetera. So maybe just a couple of thoughts on that. And Mike, I'll probably ask you to follow up as well.
A couple of things that come to mind as leaders, and this is something I think we've had to do throughout our careers, but even today in today's society, we're dealing with a workforce that is becoming more knowledgeable, has more information, more capable, and empowering them to do things that in the past, no, the supervisor had to do, or the supervisor had to do the analytic work. Even reviewing, like we're talking about these top 10 bad actors, having mechanics review that can make a big difference, empowering them that they can go extract the data because they're the ones that are hands-on with it. But I think it comes back to also, you could load them up with a lot of work and then they're just going to become overloaded, or we can do something with the results that they come back with. And as a leader, if a mechanic or a maintenance person comes back and says, okay, these top 5 bad actors, if we change the PM and do something different on it, we will have better results and get rid of the reactive work. And someone looks at it and says, okay, we'll get back to you. And then 3 months later, we still have the same stuff going on. That frustrates them, and that's not good leadership. Good leadership says, okay, you're right, let's do something about it. Let's make this change. If you're already dealing with reactive work, that's not going to kill your system to go make those changes. Do what the operator says. 9 times out of 10, you're going to see improvement, and they're going to want to do more. So the more as a leader you react and do what needs to be done in a timely manner and not wait, well, let's wait for the engineers to review this. No, let's change things now because they're asking for it now. Or feedback on a PM. Let's drop these 3 steps because we got rid of that sensor. Well, 3 months later, they're still on there. That's so frustrating. That's not leadership. Leadership, do something with the data when you get it so that can make a difference.
Agreed. Mike, did you have any thoughts on that as well?
Yeah, so I think of leadership, I think a couple different things. I think about organizational leadership, you know, the person at the top. You know, what are they driving? Is maintenance and reliability on their agenda? So the analogy I use, you know, we see transformation now, companies focus on safety, right? It's top of mind. Particularly you go in oil and gas, you start every meeting with a safety moment, right? So that's all driving cultural change. So in the same way as you look at, you know, reliability and maintenance is getting into that type of mode where leadership understands it and helping them to understand. And the trick of the trade in all the years of consulting, when we got to the C-suite, was that we would always link what we're doing to their agenda. And what I mean by that, you know, what's their personal goals they're trying to achieve and what's their organizational goals. So we kind of link with what we want to do to that. And then when that trickles down to the organization, like the department and to yourself, then it's more personal leadership, right? So as you're driving change forward, how are you acting on a day-to-day basis? How are you engaging with other departments? What are you saying? How are you acting? So being positive force in the workforce and then showing some quick wins and highlighting those and then bringing them to senior management to help them understand is typically where I see where you start to get some success and some momentum. So it's a cultural thing typically when I look at leadership. Some companies get it, others don't. I think more and more though now we see. I think predictive analytics did this. I just noticed a huge uptick in like C-suite type meetings. Is that because predictive was they thought was like the panacea? If I just throw predict on everything, I'm automatically fixed. But you still have to fix everything else we talked about underneath it. It did bring, you know, asset maintenance back into the C-suite in a positive way. So I think we got that kind of momentum behind us now that we can tap into, and then help drive change at our organization, starting with ourselves.
Good stuff, gentlemen. We do have another question from the audience. I think it's a follow-up from the last one. I'm going to ask if Carly can help us with that one again. Carly, what do you got for us?
Yeah, so previous question, they would suggest prioritizing work orders based on equipment criticality. So that was one of their suggestions.
So yeah, kind of a statement more than a question, but maybe can you all maybe comment on the role of criticality? And you kind of touched on that a little bit with the 80-20 rule that's come up a few times. But where do you see this concept of criticality really fitting in?
From my experience in the past with criticality, it comes down to what's going to shut down your operation. I mean, if you're dealing with an operation that requires steam and you have one boiler and that boiler goes down, you're not going to be producing anything at all. That means that boiler is a high critical piece of equipment. Whereas if I have 4 case packers, one case packer going down may not be as critical as the boiler going down. So understanding which ones are the higher priority, higher criticality that they're saying on there is there. But I think what a lot of people miss on there is, what is your strategy? What is your asset strategy to keep that equipment running based on that criticality? So an asset strategy for a boiler would be very different than an asset strategy for a case packer, because of the moving parts and the different components on that. So dealing with that priority, criticality, helps you decide which way to go, but adding a maintenance strategy allows you, are we doing the right things? If this asset strategy on this pump that is on wheels that we can wheel in and wheel out is run to failure, don't PM it, don't waste our time. But you may have to PM the case packer that works right next to it.
Yeah, to add on to what Nicholas is saying, the criticality I look at is understanding which assets you have that are critical. And then when that starts to trickle into the type of work, so when your planners and schedulers start to look at the work and how to prioritize work, if you have that criticality done, it's already in the system, that data is available, it's clear for them to see which of the most critical assets are. You know, sometimes resources are limited. Right? We don't have enough for the week, or we're going to bring in extra contractors, whatever it may be. That helps you to prioritize down the line which work that you focus on. And then as Nicholas talks about, what is that right maintenance strategy? Now with RCM and FMEAs being part of the suite, you can start to break it down. So if I have, you know, a set of pumps, I got redundancy, that risk of that asset failing, if one fails, it automatically fails over to the next one. That risk just went down quite a bit on that asset. So looking at it from that perspective, what type of strategies you got set up. So for instance, one company we're working with, another automotive company, on the main production line, you know, final assembly, they would have limit switches, and then after time they would wear out, the limit switch would go down, they'd shut the line down, they'd go out, change the limit switch. They came out with a brilliant idea, you know, redundancy. Redundancy made it so that it wasn't as critical. If one limit switch failed, the other one was there, that one kept working, but the PLC told them that one of the limit switch failed. So things like that, knowing the criticality, studying those assets, what's the maintenance strategy, you have the right thing in place so that the asset doesn't go down in the first place. But it also can help you indirectly, there's more to it, but prioritizing your work.
Well, one more thing for an end user on that, besides on the criticality, is if you do have a program that requires PMs and maintenance, and a lot of times people have to justify overtime or justify the number of resources. If you have a PM program in place, though, you already know the number of hours you need to do that work on there, and that justifies overtime. If you're not getting all those PMs done, you don't have enough resources for it, or you can add headcount based on that. A lot of times people said, well, they have 3, so maybe you should only have 3 mechanics. But if I go back to example, we automated a line. We took out these manual packing stations and put in robots on there. We added 3 robots to be able to do that. Well, we reduced the number of operators, and according to this company is you could only have so many mechanics per operator. So adding 3 robots meant we had to reduce the number of mechanics, even though we made it more complex in the situation on that. So same with PMs. If you have X number of PMs, and that makes a difference, and we know if we do that and they work, and we're not getting them done, that justifies overtime, or that justifies a new mechanic. And pointing those out to the C-suite is important because they just want to cut costs, but they realize you've got the equipment that needs the support. You better do those PMs, because if you're not doing those PMs, it doesn't matter what the criticality is at that point, you're just not getting the work done. You're in trouble at that point.
Right. Great. Well, listen, gentlemen, we're getting close to the top of the hour, so I'm going to thank both of you and thank our audience. It has been a great discussion. It's been great being able to tap into decades of experience with us on today's session. So thanks so much. Wrap up with just a final thought. Again, some of the research leading into this came across Alan Wiseman and some of his thoughts around this. He's a professor and kind of a futurist. And, you know, it's interesting. I think that the maintenance as an industry is kind of a victim of its own success. As long as stuff's working, no one thinks about it. But as soon as something breaks or goes wrong, it's time for the maintenance guys to come in and save everything. But I think he hits the nail on the head. The real people who hold our civilization together are the maintenance people. So tip of the cap to everybody in the maintenance and asset management space. Thanks again for joining us today. We'll look forward to meeting with you again on a future webinar and hopefully seeing you on the road at some of these events. So thanks so much, and hope you all have a great rest of your week. Take care.